Yes. Yep.
So this IPsec VPN, which we saw earlier, used CryptoMap. It used a CryptoMap. CryptoMap is where we mapped the phase 1, phase 2, and then we applied the CryptoMap on the physical interface where we want the tunnel to be initiated. For example, we had a big internet. We had an internet and we got a WAN facing interface. And the IP address over the WAN facing interface, let's say 11.1.1.1. Here 77.7.7.7. They are public IP address. Using this reachability, we want to negotiate a tunnel. We want to negotiate and bring up a tunnel which will be highly secured. Highly secured. The virtual link that you're going to, this is a virtual link. The virtual link that you're going to create will be created using this interface as the source address and this interface as the destination address. Between these two, we bring up a tunnel. With this, we negotiate and form tunnel. And anything that goes inside the tunnel is going to be encrypted, hashed, defailment group applied for integrity. So R1 decides what all traffic will go through this tunnel. For that, we wrote access list. We said if this access list matches, CryptoMap should be applied, should be a part of CryptoMap. We call that access list under the CryptoMap. And for everything, we said CryptoMap in our in site-to-site VPN. It was CryptoMap, the one which was applied on that physical link. As soon as the access list of the CryptoMap, which is binded to G0, matches, the tunnel get established. The tunnel negotiation happens, phase 1 happens. And when the phase 1 is successful, phase 2 happens for the data. So there was some time taken. That is the reason why when you pinged for the first time, you lost some packets. Because the traffic should hit the access list. When it will hit the access list, when the traffic tries to go out on G00, G00 has got a CryptoMap. Under the CryptoMap, you said match list, match IP address, the access list number. Accordingly, when the match happens, whatever is mentioned in the IPsec and ISA KMP phase 1, phase 2 is done to the data. You remember we use the command set transform set under the CryptoMap. So according to that, the encryption of data will happen. On the remote side, the decryption happens. So finally, we use the command show crypto ISA KMP SA to see the phase 1, and to see phase 2, we typed show crypto IPsec SA. And we were able to see the packets encrypted, number of packets encrypted, number of packets decrypted. This we verified on either side. Now we are going to do in a different way. Instead of using crypto map, we can also use IPsec profile. IPsec profile. IPsec profile can be binded under a virtual interface. So this is a physical interface. If you don't have an option of using a virtual interface, you create crypto map and you call the crypto map under the physical interface. What if your company policy doesn't accept this? Then you may need a tunnel interface. Interface tunnel. Interface tunnel, let's say 0. Under which we need to call this profile, IPsec profile. So we are going to see how to do this on the lab environment. I repeat, instead of using a physical interface, we would like to use a tunnel interface. Tunnel interface is a virtual interface. You're planning to form a tunnel, but instead of crypto map negotiating, you're going to use GRE to negotiate. A tunnel interface, and we are going to use IPsec profile. So anything goes inside this tunnel, anything that goes inside tunnel, which means you don't need an access list. See, when you use crypto map, we wrote access list, and we said anything that matches this access list should be encrypted. But in our current scenario, anything that goes through the tunnel need to be encrypted. Anything that goes through the tunnel should be encrypted. You see, the tunnel source and tunnel destination is this G00. But in our case, the tunnel source and tunnel destination can be a loopback interface mapped to the tunnel interface. Now, what is the advantage of using this tunnel? You see, I'm going to draw the same diagram. And we are going to have a tunnel. And there is a router on the left. There's a router on the right. As usual, we have a WAN interface connecting to the cloud. Without this WAN connection, you will not be able to negotiate with R2. That's not possible. So you still need the G00 interface, 11.1.1.1, 77.1.1.1. But we are not going to write access list, and we are not going to write crypto map. Instead, we'll create this tunnel interface which will be using GRE to bring up the tunnel. Here we are not using crypto map, we use GRE. GRE will bring up the tunnel, and then for security we will put IPsec on it, IPsec profile. I repeat, even if you don't have IPsec profile, the tunnel is there. Tunnel is going to be there. This tunnel is forever. Whereas in CryptoMap, tunnel is established whenever you communicate, and when it is idle for a time of 5 minutes by default, the tunnel will be torn into pieces. There won't be tunnel. But here, GRE tunnel is always there. And if anything goes through the tunnel, that gets protected. Anything that goes via G00 without using the tunnel, they are not going to be protected. So we are separating the functions, all the security things under the tunnel interface, the non-security things under the normal traffic flow physical interface. So what is needed is a tunnel interface. We create a tunnel and we protect the data goes through the tunnel with the same phase 1, phase 2 procedure that we were learning earlier. See, it's the same phase 1 and phase 2. Only the ending is different. In IPsec, CryptoMap site-to-site VPN, we created a CryptoMap called the CryptoMap under the physical interface, which includes access list. But here you don't need access list. The reason is because of GRE, R1 and R2 will be seen as immediate next hop. See, this is the GRE tunnel. You already got the tunnel. For GRE, let's say 192.168.1.1, 192.168.2.1. Listen carefully. We still have this G0, but here it's hidden. You see only tunnel 0. All this underlay G0, the cloud, this G0, everything is hidden because we are using tunnel 0 interface. And for tunnel identification, you need an IP address. See, end of the day, this tunnel is going to use this 11111. There is no doubt in it. Don't doubt it. This is what is used in the underlay to form this, to bring this link, virtual tunnel link. For that tunnel link, you need an IP address. No, you can give your own private IP address. These were not seen in the earlier crypto IPsec VPN. Now you may have 192.168.1. Here you may have 192.168.2.1, 192.168.3 network. All 192 your company's network. Now both the sites can ping using their own private address without getting any natting. You no need to write an access list. The biggest advantage of this is you can have one common routing protocol in these two sites, which was not possible earlier. Because you got this tunnel now, I can run EIGRP here, 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 and on the tunnel interface. They're all in one autonomous system now. Even though R1 is in London and R2 is in Sydney, they have one common subnet in between London and Sydney, 192.168.1.0 network, and you got one common routing protocol running between these two sites, GRE. And to provide protection, because you're communicating between London and Sydney. So the data goes through a common public internet. Even though that internet is hidden from you, this GRE tunnel is not strong enough to secure your data. That is why you create an IPsec profile and call the profile under this tunnel interface. So what I'm going to do as a first step is, no security related. I'm going to just take these two routers or three routers. The cloud will be one router. I'll make one router as a cloud internet. And same like this R1, R2, 11.1.1.1, 77.1.1.1. And loopbacks of R1 will be 192.168.2.1, 3.14. These are all simulating what? LAN. Got different LAN networks, 192.168.2, 3, 4, 5, and 6. And to connect between these two, we got a tunnel GRE, which is having 192.168.1.0. So we are going to do this. Let's do it. We are going to run a RIP to advertise A and B networks via the tunnel. Likewise, I'm going to use RIP to advertise C and D network. Yeah, so RIP is going to be used. RIP is what we are going to run. But to provide reachability between R1 and R2, we need the internet's help. But we don't really have an internet, so we are going to run a OSPF routing protocol so that R1 can ping R2. I'm going to use OSPF. It is always recommended to use a distance vector protocol over the tunnel, because the distance vector protocol, they don't focus on bandwidth. RIP don't focus on bandwidth, it focuses on hop count. If you use a link state routing protocol like OSPF, which uses bandwidth, then it won't use tunnel. Bandwidth of tunnel will be lesser than the physical link, because physical link is what the tunnel uses. So definitely tunnel will be having a portion of the physical link's bandwidth. So if the route is available via both the tunnel and physical, assume. If route is available via both tunnel and physical, it will use always physical. To avoid such confusions, we'll use RIP protocol. RIP is the best protocol for tunnels. Okay, so this is the idea. I'm going to go and delete the previous configurations that we had. Previously, we had this OSPF, this IP address and all. I'm going to remove, or I can put the IP address right here itself. 11.11.11.11 OSPF area 0. I don't want the crypto map. We are removing the crypto map. We do not want to use crypto. We want to use GRE. And also I want to remove this loopback interface. Instead I'm going to put what? 192.168.2.1 3.2 loopbacks. And this crypto map and all this, transform set I remove. We are going to do IPsec also from the beginning. So I remove IPsec. I could have used it same thing, but for your revision, I'm doing it once again. I could have used that same face on face. And there will be one access list that I need to remove. This is not needed. OSP is okay. That is it. So we have finished editing. Let us go and check whether the editing really works. We'll check on one router first, then we will do the same thing on other routers. Show IP interface brief. I want to see, yes, IP addresses. It didn't change. I don't know why. I edited the notepad. Anyway, let us not trust that, and I'll do it here. Interface G3 slash, or I'll use a notepad to do it quick. Wait, do show run section crypto. I need to remove all those crypto things. No crypto ISIC. Actually, we are going to do this, but I still want to do once again for you. Okay, there is one more crypto map. Done. So I should not see anything that starts with crypto now. Transform set is still there. And also, I would like to remove the access list to show run. Okay, I'm going to remove the same thing on R2. We're passing this way. So on R2 we got OSPF running on this 77777 and the interface IP address are as per what we want. And we don't have any crypto map or access list. Show access list. No access list. Show run crypto. Don't have. Good. Now one more router is left, which is R3. I'll edit one more time and save it, which we did not do on the first. So this is going to be 11, 11, 11. This is going to be 77. Voice professorchandran. There is no other changes. I save it and I start it. What I'm expecting is two OSPF neighbor. When this router comes up, I should see router 1 and router 2 as neighbor. See, one OSPF neighbor has come, which is 5.1. That is R2. So something is wrong with. See, this is just a router ID, so don't worry that we are not running OSPF on this 5.1. That's OSPF router ID. Now, show IP OSPF interface brief.
In R1 we have not started OS.
R1, okay. Let me try pinging this. This is not pinging. You know why the problem is? I made a mistake. It's not 11, 11, 11. It's 11, 1, 1.
Yeah.
Now the neighborship will come. Again, I did same
Ping
ping mistake.
11.1.1.1.
Yeah. It is okay. Let's go to R1 and check. Oof. From where this 13 comes? Okay, the neighbor should come now. I'll go to R3 and try pinging. Okay, the neighbor has come. Already come. So let us ping from here 77.7.7.3. Sorry, 7. Which is R2. I'm able to ping from between R1 and R2. I'm able to ping between R1 and R2. With this reachability, we can form GRE tunnel. So I'm going to form GRE tunnel. Please pay attention. Interface. Before that, show IP route. The loopbacks still did not change. Let me go and change the loopbacks. Interface loopback 0. IP address is 192.168.2.1. If you see show IP route, you don't have routes to reach the remote loopbacks, do you? You don't have. You don't have routes to reach the remote LAN. C and D, you cannot ping from A and B. Likewise, on router 2, you don't have routes to reach A and B. You don't have routes. And if you check the internet has got no idea about 192. Anyway, let us go to R1 and form tunnel. And I'm going to say tunnel source is G3/0. Tunnel destination 77.7.7.7. Tunnel mode GRE IP. Likewise, I'm going to router 2, say interface tunnel 1, tunnel source G3/0. Tunnel destination 11.1.1. Tunnel mode GRE IP. So this is GRE. The tunnel is come. The tunnel is already come. But to identify the tunnel, we need to give IP address. Please closely watch. I'm giving this IP address now. This tunnel is already up, and now I'm going to give this IP address to the tunnel end. I want to show you again, tunnel is up. How? Show IP interface brief. You see, the tunnel is up. But you have not given any IP address. Let's assign IP address. Now let's go and see here. There should be an IP address on the tunnel interface. We do have. Now let us go to R2. Oh no. I have configured an R2. I want to change it. Show run interface tunnel 1. Correct. Now this is what we have in tunnel interface. Where is the mode GRE IP? I configured, but it is not shown here because it is default. Even if I would have not configured, it is going to be GRE IP. If you want, you can see that. Show interface tunnel 1. You see here GRE IP is the transport. Now, I'm on R1. Interface G3/0. IP address, sorry, not interface. Interface tunnel 1. IP address is 192.168.1. See, if GRE tunnel is up, I should be able to ping between this private IP address. Show IP interface brief. Look at this brief. If this is there, I should be pinging the remote site. Remote site is what? .2. Ping. It pings, which means your tunnel is up. See, please understand, R3 has got no idea about this 192. R3 has got no idea about 192. but you are able to ping from R1 to R2 via R3. It is because tunnel. Because it's going through the tunnel, R3 will not see the original source and original destination. When you ping this 192, no, it will not, even though it is going via G3/0, it will be encapsulated and going through it. You see, when you try pinging this address, 192.168.1, where is the maximum prefix match here? So it will try to push the packet only via tunnel 0, sorry, only via tunnel 1. When it tries to go via tunnel 1, if you see the tunnel 1 configuration, it is going to put this address, the address on this interface as a source, and this as the destination, and deliver the packet here. So the middle router needs to know only the route to reach 77. Even though you are pinging 192.168.1.2, it is actually delivered to 7777 when you go through the tunnel. If you want, I can show you by sniffing the packet. Yeah, I'm going to ping again. And Wireshark is at the background. Okay, I stopped the ping. Now you see, the packet was going from 192.168.1.1 to the destination 192.168.1.2. But what happened? GRE comes in the middle, adds the tunnel source as 11.1.1.1, which is the left-hand side router, tunnel destination. So this encapsulation is what GRE does. But it is not encrypting. You see, the payload can be visible. This is the data that you sent. ABCD 10621 ABCD 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 ABCD. How many ABCD? See, whenever you ping, no, some data should be sent. No, so operating system will simply put some data. So data is visible, not secure. To provide security, we need IPsec profile. All right. After creating IPsec profile, I'll bring you back. So what we have done so far is here return. I'm going to run a RIP between R1 and R2's LAN. When I say LAN, it includes this channel also. Listen carefully. I'm an R1. I'm going to say router RIP version 2. Network 192.168.1.0, 2.0, 3.0. No notice. 1 means the RIP will be running on tunnel interface. 2 means this back. 3 means this back. I need to do the similar configuration on router 2. I'm expecting now via the tunnel RIP will be advertising. Via the tunnel. You see? Show IP route now. RIP routes. You see? Via tunnel 1, you learned the remote networks. R3 has got no idea about these networks. No idea. We don't even run RIP here. So now A can ping C. Let's ping. What is C address? 192.168.4.1. Source 192.168.2.1, which is A. I'm pinging from A to C. The ping happens like that because you have merged London and Sydney by putting one tunnel. So no routers in the middle need to know any routes of your private network. Successfully, we have done the tunnel. Only thing is left is the protection to the tunnel. Right? I'm going to do it really quick because this is a known story. Crypto ISAKMP policy 10. Encryption use 3 days. Authentication use pre-shared key. And then hashing use MD5. And then group defilement group used to do show history. I'm going to copy these lines and put it on router 2. Next is, please listen, crypto IPsec transform set T set. I'm going to encrypt the data using ESP des. I don't want to hash it. Okay, so I'll paste this on. It's your wish. You can add another algorithm for hashing, but I don't want to make it more process consuming. Next. Now this I need to put it in a profile. Crypto IPsec profile. I'll say site to site. And then set transform set T set. Okay. That's all needed. Next is you don't need to write access list because already the routes are going through the tunnel. Or whatever goes through the tunnel you want to encrypt. No. All that you need to do is you need to call this profile under the tunnel interface. Okay. So let me put this on R1 also. Yeah. Now going back to interface tunnel 1, tunnel protection using IPsec profile. What is the profile name? Yes, that's it. Go to the other side also. Pre-shared is missing. Correct. I did not give the key. Crypto ISAKMP key. Cisco 123. Address. With whom you are forming this? 77.7.7.7. Alright, now that complaint won't come. I put the pre-shared key. Now the same pre-shared key I need to put it on the other side. And the address will be 11.1. Done. Now what is next is go to the interface tunnel 1. Tunnel protection using IPsec profile. The profile name is STS. That's all. Our ISAKMP IPsec VTI, virtual tunnel interface, is going to encrypt from now on. Let us go now to the Wireshark and capture. You see, earlier when I was pinging, you were able to see the ICMP data. But now I am pinging, you will see only ESP. You will not see any data. All right, I'm going to ping now. Boom. You see, this is the ping. I stop the ping. Now, if you go up and see, it is ESP. So the original 192 is missing, you see. It is just showing the packet is going from 11.111 77.7. Encryption using ESP des for the payload is happening. That is what I gave, des, ESP des. ESP stands for encapsulating security payload. So you don't see an ICMP packet, instead you see ESP packet. You can also see this on the command line. If I now go and check here, show crypto IP ISAC and PSA, you see the tunnel up between these two. And then if you say show crypto IPsec SA, you can see there are 9 packets encrypted and decrypted. Alright, so this is using the tunnel interface, tunnel 1 interface. We don't use cryptomap, we use tunnel. We call it as VTI, virtual tunnel interface. Question please.